Hello, my name is Rick Gilbert and I'm the director of NASA's John C. Stennis Space Center. Stennis has been on the forefront of human space exploration since the 1960s. Every Apollo astronaut who walked on the moon had their rockets tested right here in Hancock County, Mississippi. We also tested the Space Shuttle main engines for 34 years, accumulating over 1 million seconds of test data. NASA is now embarking on a bold new program called Artemis. Artemis is the twin sister of Apollo and the goddess of the moon in Greek mythology. This program's stated goal is to land the first female and the next male on the south pole of the moon by 2024. That journey will be powered by the Space Launch System core stage that we'll be testing right here on this B2 test stand. We're proud of what we do here, so come join NASA as we go forward to the moon and on to Mars.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
In 1961, President John F. Kennedy challenged this country to send humans to the moon and back. To do that, NASA needed rockets, big rockets. They needed a place to build, launch, command, and test those rockets. For testing, NASA needed a location with lots of room, access to water, good weather year-round, and a supporting community. After considering several locations, a largely uninhabited, rather untamed area in Hancock County, Mississippi fit the bill best. NASA made the announcement on October 25, 1961. The space race was coming to South Mississippi. There were challenges to overcome. NASA had to win local sentiment for its plan. Building Stennis required relocating residents in several small communities. U.S. Senator John C. Stennis, the site's eventual namesake, paved the way, promising citizens their sacrifice would contribute and lead to something great. NASA bought a total of 13,800 acres to build the site. This is called the fee area because it was purchased outright. All site facilities are located in the fee area. NASA also acquired the rights to another 125,000 acres encircling the fee area, primarily through permanent lease. This area is left undeveloped to serve as a buffer zone against the noise and power of rocket engine and stage tests. The buffer zone extends outward from the fee area for several miles in all directions and still is considered a national asset. NASA was racing a clock that began ticking with President Kennedy's challenge. Time for launching a moon mission by the end of the decade was short. In South Mississippi, workers battled snakes, rain, mosquitoes, mud, heat, hurricanes, and even an unseasonable snowfall to build the facilities and massive structures needed for testing Apollo program rocket engines and stages. The construction project was the largest in Mississippi at the time and one of the largest in the nation. At one point, 6,100 employees were on site, representing 30 prime contractors and 250 subcontractors. The moment of truth came in the spring of 1966. Test operators worked through the night at the recently completed A2 test stand, preparing for the site's first test. At 7:27 a.m. on April 23, 1966, the South Mississippi silence was broken by the roar of 21 million horsepower, equal to 52,500 race car engines. The test of the first Saturn V rocket booster lasted only 15 seconds, but it ushered South Mississippi into the space age and set the nation squarely on its way to the moon. South Mississippi has remained at the forefront of America's space program ever since. During the Apollo program, Stennis tested every first and second stage of the Saturn V rockets that launched humans to the moon. In the process, Stennis personnel totaled 2,475 cumulative hours of testing experience and expertise. During this space shuttle program, Stennis tested every engine that powered astronauts on 135 missions. It also tested the Space Shuttle Main Propulsion Test Article, a network of 3 engines firing simultaneously. The test article was installed on the B-2 test stand, and all 3 engines fired just as during an actual launch. The testing was critical. NASA had to make sure its system of 3 engines would perform as needed. There were no test flights for the shuttle. The first time it launched in 1981, it carried a pair of astronauts. Stennis made that possible. All of the original large rocket stands were involved in those test projects and have been historically recognized. Today, Stennis stands as the 2nd largest in terms of geographic size of 10 NASA centers in the United States. It has grown into a large federal city site with more than 50 resident agencies. The various tenants share the operating expenses of the site while working on individual missions. It is a great and very cost-saving partnership. Tenants span the spectrum from Lockheed Martin to Mississippi State University, to the National Oceanic and Atmospheric Administration, to the Mississippi Enterprise for Technology. The largest and most historically significant tenant on the site is the U.S. Navy. The Navy arrived at Stennis in 1975. Its move was critical in the development of Stennis as a federal city. The Navy now has several offices at Stennis, including the Naval Research Laboratories and the Naval Meteorology and Oceanography Command, which administers a worldwide organization of 3,000 naval officers and personnel. The Navy also conducts riverine gunboat training on Stennis waterways. The largest collection of oceanographers and hydrographers in the world is located at Stennis, and the site is home to the only active-duty naval admiral located in Mississippi. All in all, more than 5,000 people work at Stennis Space Center, and they live as valuable members of surrounding communities. The majority of Stennis employees reside in 3 Mississippi counties. However, 30% also live in neighboring Louisiana. The Stennis workforce comprises a diverse group from all walks of life. Year in and year out, half hold a college bachelor's degree or better. Typically, about 15% hold a master's degree, and up to 5% have earned doctorates. About 60% of Stennis employees work in scientific, engineering, or technical positions. The rest fill business, professional, administrative, and other roles. Together, they form a Stennis team that are characterized as a family. The NASA team pursues a full mission to support space exploration. They work to develop and share space-related technology with the larger world, to tell the NASA story, and to encourage young people to pursue activities and careers that will make them the science, technology, engineering, and math leaders of tomorrow. It all adds up to a pretty influential and powerful place. Annual studies show Stennis is a major economic engine for the entire Gulf Coast region. It offers a range of employment opportunities with an average salary and benefits of about $90,000. Decades after it was established, testing remains the heart of all Stennis is and does. The site is widely recognized as a center of excellence for rocket engine and stage testing. It currently is testing engines that will carry astronauts aboard NASA's new Space Launch System, which will fly further and deeper into space than ever. Stennis test stands and facilities are valued at more than $2 billion. If Stennis and its buffer zone did not exist, NASA would have to build something like it in order to test the engines and stages it needs for space missions. Rocket scientist Wernher von Braun said it first, and folks at Stennis still say a version of it now. If you want to get to deep space, you have to go through South Mississippi. A look at the Stennis test area shows the complexity and value of the site. A high-pressure gas facility produces 4 high-pressure gases needed for testing rocket engines and stages: nitrogen, helium, hydrogen, and air. The gas facility went online in the mid-1960s and has remained in continual operation 24/7, 365 ever since. There are facilities for handling the rocket propellants or fuel needed for testing. These are fuels like liquid hydrogen and liquid oxygen that require precise care. Stennis is among the world's largest consumers of liquid hydrogen. Trucks regularly deliver the liquid propellants needed for testing. These liquids are stored in well-insulated tanks because they are kept at super cold temperatures, as low as -450 degrees Fahrenheit. Propellants are delivered from the tanks to the stands for testing by specially designed barges using a 7.5-mile canal system. The canal system connects the Stennis test stands to the East Pearl River, so large rocket stages can be delivered by water transport. The stages enter the Stennis system by traveling through a smaller version of the Panama Canal lock and dam format. A high-pressure water facility provides the water needed for testing. The water is pumped from a 66 million-gallon reservoir. Testing can use as much as 335,000 gallons of water per minute, which is considerably more than what you get out of a garden hose. Some pipes in the test complex water system are 96 inches in diameter. Team members conduct engine tests from a pair of test control centers. As you would expect, no one can be on a stand during a test. There is even a wide safety area which no one can enter. You have to view tests from a safe distance. No doubt, the test stands are the main attraction of the center. Stennis actually features 3 test complexes with different stands. The E-Test Complex is the newest area, built in the late 1980s and early 1990s. It has 3 smaller stands with 7 separate test cells. It offers versatile options for testing engines and components. Companies such as Aerojet Rocketdyne, SpaceX, and Blue Origin have used the complex for test projects. Stennis also has entered into an agreement with Relativity Space for use of an E-complex area. The A-Test Complex has 3 test stands, A1, A2, and A3. The B-Test Complex has 1 stand with side-by-side test capabilities, B1 and B2. Each of these large concrete and steel stands are marvels of engineering. As tall as they are, they also extend far into the ground, from 50 to almost 150 feet. They have to be solidly anchored. All of the same power that lifts a rocket into space is felt on the stand during a test. The stand has to be strong enough to hold the engine or stage in place and absorb all of its force. On the stands, rocket engines and stages are installed to fire downward into a large flame deflector made of solid steel. The exhaust from a rocket engine can reach 6,000 degrees Fahrenheit, which can melt the steel. To keep that from happening, tens of thousands of small holes are drilled in the flame deflector. Water from the high-pressure system is pumped through these holes to cool the engine exhaust and protect the flame deflector. Now you know why so much water is needed. Of course, when water hits extreme heat, it produces steam. That is the billowing white cloud you see exiting the stand during a test. If the wind is blowing right and the cloud passes overhead, you will experience water vapor rain. Stennis tests engines and stages just as they must operate during an actual mission. An engine may fire a little more than 8 minutes to lift a rocket to space, so 500-second tests are customary. When astronauts climb aboard a rocket powered by engines tested at Stennis, they know the engines can perform as needed. No crewed space mission has ever failed as a result of the malfunction or failure of an engine or stage tested at Stennis Space Center. While similar in construction and function, each of the large test stands has unique capabilities. The A1 stand can gimbal test an engine. Gimbaling is when an engine is tilted a few degrees in any direction to direct the thrust. Since a rocket has no steering wheel, the engine must be gimbaled to keep it on the proper flight path. The A2 stand can test engines at simulated altitudes up to 60,000 feet. The A3 test stand is designed to test at simulated altitudes of up to 100,000 feet. That is an important capability if you want to make sure a rocket engine will operate in space. The B1-B2 stand is the largest of the test structures at Stennis. It towers more than 350 feet, ranking it as one of the tallest structures in Mississippi. The 7,000 tons of steel in the stand is about as much was needed to build the Eiffel Tower. The stand also has 86,000 cubic yards of concrete, estimated as enough to build a sidewalk from Stennis to Memphis, Tennessee. The B1 side of the stand is used for single-engine testing. The B2 side is designed for stage and main propulsion system testing. Stennis truly is a unique and historic site. It is a great story, and we have only skimmed the high points. The best part is, the story continues to be written. As Americans return to the moon, they will ride on rocket engines and stages tested at Stennis. When they ultimately head for Mars, they will be launched from Earth by Stennis-tested engines and stages. As long as humans aspire to travel to other worlds, as long as they reach for the stars, they will need powerful rocket engines and stages to take them there. They will need a place to test those engines and stages, a place to prove what is possible, a place to power their space dreams. They will need Stennis Space Center.